There is another handout on background notes. This one is on transformations, and I'm going to just refer to it briefly here. You can refer to this, the PDF in Canvas, if you want to study it in more detail. So this handout just refers to vertical and horizontal shifting of graphs and how it's related to equations. I'm just going to talk briefly about these examples. We all know the graph of y equals x squared. Here it is, right here pictured. And if you compare the graph of y equals x squared plus 3, which is another parabola, another quadratic function graph, the graph of y equals x squared plus 3 looks just like the graph of y equals x squared shifted vertically upward 3 units. Another pair of examples to look at is example 2, y equals the square root of x, and y equals the square root of x minus 2. Here's the square root function graph right here, and if you graph y equals the square root of x minus 2, you get a similar shaped graph, but it's shifted down vertically 2 units. So in general, for any constant d, we can shift the graph vertically to obtain the graph of y equals f of x plus d. We go upward if d is positive, downward if d is negative. On the next page, example 3, we look at horizontal shifting, and there's a little bit of a twist to things here. Compare the graphs of y equals x squared and y equals x plus 3 in parentheses squared. And here are the two graphs. Again, our favorite quadratic function graph and a transformation of it. So notice that when we graph y equals x plus 3 in parentheses squared, the graph that we get is actually shifted to the left 3 units, which we tend to think of as a negative direction. And so even though we see a plus sign in the formula, we have to shift the vertex over to negative 3. And the reason this happens is because to get the same y values, you need to use x values that are smaller by 3. But however you think of it, you really just got to memorize this fact. So it's a little bit counterintuitive with horizontal shifting, right? And it contrasts with, it's not in sync with vertical shifting. And example 4 is just similar. If we take the square root graph and the graph of y equals the square root of x minus 2, where the minus 2 is inside the square root sign, the graph that we get for the x minus 2 function is shifted to the right 2 units in the positive direction. And so the general statement is for any constant c, we shift a graph horizontally to obtain the graph of defined by the equation y equals f of x plus c in parentheses. We actually move to the left if c is positive, and we move to the right if c is negative. So it's a little bit counterintuitive with horizontal. It's also it's not counterintuitive for vertical, so they're different in that way. And I have some exercises here you can practice if you need some practice on this. Just taking a given graph, so I give you a graph of a function here, no formula, and I just ask you to draw these transformations. And I believe the answers are all attached to that handout. So that's all that we're going to say here about this handout on transformations. We're going to move right on to some trig problems where we deal with vertical and horizontal shifting.